how do we evaluate heuristics? So there are two questions. First, whether a heuristic is a good model for decision-making by experts or the lay people. That's one question. That's the descriptive model. The second evaluation is the normative one, whether a heuristic is a good model for the job to do. And that's a big difference, because heuristics in almost all psychological research are only used to address the first question, the descriptive, because people think they are not very good, which is an error. And so we address both questions. The normative question, that's the question of ecological rationality. That can be analyzed by mathematics. So I have an interdisciplinary group with people from mathematics, computer science, psychology, from economics, from evolutionary biology, philosophy, and many areas. That's also an important part to make progress, by having a heterogeneous group that knows things. And I learn every day something new. I'm not bored. So mathematics is one way to answer this. For instance, one can prove certain theorems that in certain situations, reasoning by one good reason is always as accurate or more than any linear model. That can be proven. But the real world is more messy than that. And that's where you need computer simulations with real world data, with artificial data, to understand the question of ecological rationality. That's sort of the two basic tools for study of ecological rationality. For the descriptive question, whether a given heuristic or which of a number of strategies is the best model to describe what a person does, you need experimental research. There are some methodological points that I feel are very important. Psychology is a field with lots of statistical training, but several basic principles are not always in place. And in order to answer these questions about heuristics, just like in any other question, the first thing is we need to have the model first, or the theory, the hypothesis, and then the data. And often it's the reverse. This is why we insist on formal models of heuristics in order to be able to test them. There's an entire different tradition in psychology where you have a phenomenon and then you have what's called a heuristic. It's basically a word, like availability, with which you can explain almost everything between heaven and earth after the fact. But you can't predict with these things. Yeah. And so that's the first methodological principle for studying heuristics. Have the model first, derive predictions, and then test it. The second principle is do competitive testing, not one model, and then you find some fit, and then you're happy if you like your model, or you criticize it, it's too little, if you don't like it. But do competitive one. What we need is theories that do better than others. And in our research, we try to test, whenever it's possible, multiple models, including optimization models, to understand in which world which one works. So this is two important principles that are partially in conflict. What many psychologists have been taught to do, like null hypothesis test and significance test. You don't need them. You really have several competing models rather than a null hypothesis, and you don't specify your model and you claim victory when the null is being rejected. That's not a strategy. A third important methodological principle is to evaluate a theory or hypothesis not by the fit with the data, but with its predictive accuracy. Fitting means you already know the data, and then you fit your parameters, and then you have an R square of 0.8 something, and you're happy. But fitting always depends on the number and kind of parameters. The more you have, the higher you get your R-square. And if you have as many parameters as data points, you always are 100%. That's not what science should be about. A person, an animal, has to predict, not fit data. So there are many techniques. The simplest one is cross-validation. You fit your model on one, and then you predict the other thing. And that's the crucial test. Some heuristics have no free parameters, so the difference between fitting and prediction isn't there. But most models in psychology have quite a number of parameters, so this is very important, not to evaluate them just by fit. So these are some of the methodological principles that are needed to get an understanding about what heuristics people use and also in which world they succeed.